Welcome to video lesson 9.1 on solving quadratic equations by graphing. So we're going to learn how to get the solutions or the roots of quadratic equations by graphing, and in chapter 7 we did that by factoring. So today we're going to be graphing equations that are in the standard form of ax squared plus bx plus c. Okay, and we're going to be, in order to solve, or our solutions are going to be the x-intercepts. We're either going to have one solution, two solutions, or no solutions. Okay. Our first equation that we're trying to graph is y equals, or x squared plus 2x minus 3. Here we're going to rewrite this in this form. Okay, y equals x squared plus 2x minus 3. Again, remember the quicker way of graphing that is to use the vertex, okay, and the y-intercept to be able to graph this parabola. So in order to find the vertex, we have to do the opposite of b over 2 times a, okay? So x equals negative 2 over 2, which is negative 1. That's our axis of symmetry, okay? And then we'll find the y coordinate. So negative 1 squared plus 2 times negative 1 minus 3, okay, which is 1 plus negative 2 minus 3, negative 1 minus 3, and look, I already had y equals negative 4 there from before. Okay, so my vertex is negative 1, negative 4. My y-intercept, I can see here, is negative 3. Using the axis of symmetry as negative 1, I can see I'll have another point over here. Okay, and then I can just draw my parabola. Now what I'd like to do, since this doesn't really tell me am I going to go way out here or way out here, and the x-intercepts are really important, so I'm just going to get one more point, because if I can find when x is 1, that'll give me the point along this line, and that'll be helpful. Okay, and then if I am still below the x-intercept with that point, then I'll probably pick when x is 2 so I can get a point above the x-intercept to make that x-intercept more accurate. So if x is 1, okay, what is y? Well, 1 squared is 1, plus 2 times 1 is 2, minus 3. 3 minus 3 is 0. So I have the point 1, 0 also on this parabola. And since I have the point 1, 0, with the line of symmetry, I'll be 2 away. I also have the point of negative 3, 0. Now I can draw a more accurate parabola. Okay? And my x-intercepts are my solutions. Okay? So I write that as x equals negative 3 and x equals 1. Those are my solutions, or what's also called the roots of this function. Okay, now I'm going to graph x squared minus 8x equals negative 16. So first I want to rewrite this into standard form. So I'm going to add 16 to each side, and that equals 0. Then I can write the related function. Okay, so I'm just replacing really 0 with y. And now I have to actually graph that. So I need to know the axis of symmetry and the vertex. So that'll be 8 divided by 2. So x equals 4. When x is 4, okay, 4 squared, 16, minus 32, plus 16. So negative 16 plus 16 is 0. Okay, so I have the point 4, 0. And the y-axis is 16, so that's going to be point way up here, higher than that. Okay, so then if my axis of symmetry is 4, I'm going to find up here. Oops. And here. That's a better parabola. Now we can see we're only intersecting the x-axis at one point, and that's when x equals 4. So this graph only had one solution, the last one had 2. And in example 3 will be a solution of when we only have 0 solutions, because it may not intersect the y-axis at all. Our first step is to rewrite this, so I'm going to add x squared to each side. Okay, and then I'm going to write that as an equation, that function. Now again, a graph, I'm going to be taking negative b divided by 2 times a, so that's going to be x equals negative 2. So negative 2 squared is 4, plus 4 times negative 2 is negative 8. Okay, so negative 4 plus 5 is 1, so the vertex is negative 2, 1. And now the y-intercept is 5. Okay, 1, 2, 3, 4, 5. So I also know there's another point that's going 2 over 2 over 5. I can draw my parabola here. And I can see that this is never going to intersect the x-axis. So I have no solution. Okay, and sometimes that will happen. And that's what the graph will look like if there is no solution. Couple of review parts for you. Quadratic equations may have 2 real solutions, 1 real solution, or no real solution, and that just shows you a picture of it. So if the parabola is going through the x-axis twice, then you'll have the 2 solutions, or the 2 roots, okay? The 2 zeros. And then if your vertex is right on the x-axis, you're only going to have 1 solution. Now remember, this could also be opening downward, okay? And so could this. Could be going downward as well, okay? Doesn't always have to be an upward parabola. So it would have a solution, just none of our examples were negative a values this time. And just like example 3, we could have no real solutions because there's no x-intercepts. This is just showing you that of this equation, x squared minus 6x plus 5 equals 0, that you could call the solutions or roots x equals 1 and 5. The x-intercepts are also 1 and 5, and the zeros are 1 and 5. So all of those names are kind of synonymous with the same thing, finding the x-intercepts or the solutions of this quadratic function. And you have 4 practice problems where you're going to graph each of them. First, you may have to write the graphs in standard form, then use the axis of symmetry and find the vertex and the y-intercept to be able to graph your functions, and find the x-intercepts as your solutions. Make sure you write down any questions you have, and have a great day.